All right, in this video, we're going to talk about kind of the next thing that has to do with like fractions and negatives and stuff. And that is changing fractions to decimals. So our I can statements, I can convert fractions to decimals. Okay, and so while you're writing that down, the reason this is in this unit is that because fractions are just division problems, okay? So it kind of goes with the whole dividing, and then we can throw in negatives, and then it goes into the negatives thing we've been working on. So we call this converting between rational numbers, and rational numbers are numbers made from dividing to integers. Okay. So it's gonna require some long division. It's not too bad though. I thought it went away. Who knows what that was? So 1/4 is really just 1 divided by 4. So when I do this long division format, the 1 goes inside the little division hut. Let me see if I can change our lighting to be a little, and then 4 goes on the outside. And then we would do division like normal. So how many times does 4 go into 1? Well, it doesn't. So what do? I add a decimal point. Okay, so 4 goes into 1 0 times. And then I add a 0. So now the question is, how many times does 4 go into 10? Well, 4 goes into 10 2 times. 4 times 2 is 8. We have 2 left over. And I want to do this till I don't have a remainder anymore. Okay. So I'm going to add another 0. Bring that 0 down. 4 goes into 25 times. And we don't have a remainder. So 1/4 as a decimal is 0.25. All right, same thing for 1/5. We're going to do 1 divided by 5. So 1 goes inside the little division hut, and 5 goes on the outside. 5 does not go into 1, so I'm going to write a 0. Then I add a decimal point and a 0. 5 goes into 10 perfectly 2 times. No more remainder. So 1/5, or 1 divided by 5, is 0.2. All right, 1/8. 1 goes inside the division hut. 8 goes on the outside. 8 does not go into 1. So add a decimal, add a 0. 8 goes into 10 1 time. I'm left over with 2. I'm out of numbers, so I'm going to add another 0. Bring that 0 straight down. 8 goes into 20 2 times. 2 times 8 is 16. We still have a remainder of a 4, so I add yet another 0. Bring that 0 straight down. Then 8 goes into 40 5 times. Finally, no remainder. So 1/8 is 0.125. Right, 7/10 as a decimal. 7 divided by 10. So 7 goes inside the division hut. 10 goes on the outside. 10 does not go into a 7. So I'm going to add a decimal and a 0. 10 goes into 70 7 times. So 7/10 is 0.7. Queens. Okay. All right, so to change fractions to decimals, we divide the numerator. That's the top number. And we divide it by the denominator. or the bottom number. Okay. All right, so using our positive and negative rules, this is negative of 1/2. So I'm just going to tell you, well, we'll just work our way through it, okay? All right, so I'm going to find 1/2 as a decimal of 1 divided by 2. 2 does not go into 1, so I add a 0 in a decimal place. 2 goes into 10 5 times. So this is saying negative of 0.5, which is just negative 0.5. Okay. All right, so negative 1 divided by 2. Let's just do 1 divided by 2 first. 2 does not go into 1. So I add a decimal, add a 0. 2 goes into 10 5 times. Hint, hint, they're kind of the same fraction. So we should have the same decimal, okay? But then, write our minus, minus, plus. I see a negative, so I cross that off, and I see a positive, so I cross that off. So my answer is going to be negative. So negative 1/2 is negative 0.5. Right, 1/-2, where we're still going to do 1 divided by 2. 2 goes into 1 0 times, add a decimal, add a 0. 2 goes into 10 5 times. And then write our minus, minus, plus. 1 is positive, 2 is negative. Our answer is going to be negative. So look, these are all equivalent. They equal the same thing. So if there's a negative, it can either be in the numerator, in the denominator, or outside, okay? So the negative can either go outside of the entire rational number or in the numerator or denominator. But it can't be in both places because if I have negative 1/-2, okay, it's going to be some version of 0.5, okay? We do our minus, minus, plus. There's a negative, and there's a positive. If the negative is in both, it's not the same, okay? So we got to pull. I had a thought, who knows what it was. It went away. It's the end of the day. Okay. All right, so numerator, the top divided by the bottom each time. And then if the negative is in front, it can either go to the top or go to the bottom, but not both. All right, and then the rest of it is just the same idea, using our long division methods and adding our negative rules.